Today we're going to be starting Unit 3 of Geometry. This is all about theorems of triangles. Now, next term, we will still continue looking at triangles. But right now we're looking at various parts of it and relationships that happen when we have add-in segments and add-in rays, as well as proving triangles are congruent. So starting off, triangle is a polygon or a many-sided figure with 3 sides and 3 angles. Now to name a triangle, we need to use 3 vertices or 3 angles. For example, the triangle that is off to the side, we have 3 angles of A, B, and C. So we would have a picture of a triangle, just like how we did for an angle, in those points, A, B, C. Now, if you don't have that triangle in front of it, we do not know what we're talking about. So make sure you have that in front if you're talking about a triangle. Interior angles are original angles formed inside the triangle, just like how we talked about alternate interior angles, or the angles inside of parallel lines. And then it's going to be the same thing with exterior. Exterior angles are formed outside the triangle, creating linear pairs with vertical angles. Linear pair, remember, 2 angles adjacent to each other that make up a line. So they are supplementary. So for example, in this problem, we know that the 87 is an exterior angle, it's outside. So if we want to find this interior angle, we're going to need to do x plus 87 equals 180. Subtract 87 from both sides, and we get x equal to 93. So that angle inside would be 93 degrees. Well, if we take a moment and just look at the relationship between the 93, the 35, and the 52, or our 3 interior angles, something that kind of special happens with them. 93 plus 35 plus 52 gets us 180 degrees, which gets us to this idea of triangle sum theorem. All interior angles of a triangle add up to 180 degrees. So there may be a time where we have to find x and find a value inside. So we add all 3 angles together, set equal to 180. This will always work for triangles. So let's kind of prove that this works. So for this proof, we have a given statement. Given statement says triangle ABC with line AD parallel to segment BC. So because we said parallel, we have those relationships that we talked about in the last unit. So those 2 lines, or line segments, are parallel. So we could have a transversal. And in fact, in this problem, we have 2 transversals. That would be a transversal. So the relationship that I notice here is between angle 1 and angle 4. I know angle 1 is congruent to angle 4 because of alternate interior angles. Now we do have a slight dilemma. In this problem, we have a congruency symbol. However, if we look at our proof statement, it has an equal statement. So we need to switch it to an equal. So I can do that. I can say angle 1 equals angle 4, because that's the definition of congruence. So that was a transversal. I also have another transversal here. Looking at that relationship, I see angle 5 and angle 2 are congruent because they are alternate interior. So angle 5 is congruent to angle 2. Because of the alternate interior angles. Now, just like before, we need to be able to switch it back to an equals. So angle 5 equals angle 2. Definition of congruence. Now we're going to reach all the way back to Unit 1. Unit 1, when we talked about supplementary, it ended up saying angles that add up to equal 180 degrees. Now, we've always had supplementary pairs, so 2, but we could have more than 2 angles. So, for example, angle 4, 5, and 3 are supplementary. They add up to equal that line. So I can say the measure of angle so let's say a measure of angle 4 plus a measure of angle 5 plus a measure of angle 3 equals 180. They're supplementary angles. Now, unfortunately, we do have one last step. We have in our proof measure of angle 4, which we know is the same thing as 1. So I can replace the measure of angle 4 with the measure of angle 1. We know the measure of angle 5 is the measure of angle 2, so I can replace that. And we can leave the measure of angle 3. That is our proof statement. And we plug stuff in, so this is substitution or transitive. Property of equality. Equality because we have an equal sign. So let's look at these examples. First one, what is a measure of angle T? Well, we're missing it. So I'll just put an X. We have 3 interior angles, so all 3 have to add to 180. So X plus 27 plus 82 equals 180. Combine like terms. So X plus 109 equals 180. Subtract 109 from both sides. And we get X equals 71. Looking at the next one, 3 interior angles again, we're solving for X. So we can write 8X plus 2 plus another angle, so plus 70, plus the third angle, so 60, equals 180. Combine like terms, so the 2, 70, and 60, we get 8x plus 132 plus 180. Subtract 132 from both sides. You get 8x equals 48. Divide both sides by 8. X equals 6. Go ahead and pause the video and try doing this third one. So all angles of this triangle say x. So x plus x plus x equals 180. Combine like terms and we get 3x equals 180. Divide both sides by 3. X equals 60. Now this type of triangle, because all angles are the same, this is our equilateral triangle, which we'll talk about later on in this unit. This one actually has a slightly different name besides equilateral. We have one last theorem to talk about. And this deals with exterior angles. So we have an x outside. Well, we have an issue because the x is outside, not inside. So we need to find out what x is. Well, if we call this angle y, we could find y. You know, all three angles inside add up to 180 degrees. So I'll write that. Y plus 60 plus 70 equals 180. Combine like terms. So y plus 130 equals 180. Subtract 130 from both sides. Y equals 50. So I know this angle inside is 50 degrees. Not only that, but we know that the x and the y are a linear pair. They're right next to each other and they add up to 180. They're supplementary. So I'm going to say x plus that 50 equals 180. Subtract 50 from both sides. X equals 130. Now, didn't we say 130 before in this problem? Well, we got 130 by adding the 60 and the 70. Which that actually leads us into our exterior angle sum theorem. It says two non-adjacent interior angles add up to the exterior angle. So it's our two far inside add up to equal our outside. So let's actually use that for this problem then. So our two far interior add to equal our exterior. So in this case, x plus 70 equals our exterior of 2x minus 5. We have an x on both sides, so subtract x. 70 equals x minus 5. Add 5 to both sides. And x equals 75. Now, the problem does go on to say, then find the measure of all angles in the triangle. So we know angle L is 70. measure of angle J would be 75. And then to find that third one, the measure of angle JKL, measure of angle JKL, we're going to need to do the 180 minus 70 minus 75. Doing so, we end up getting 35 degrees.